I think I'm just gonna bother turn mine on.
Okay, just. Let's see. What bed is here? Last seen today at 5:52 a.m. Huh?
You have a lot of crypto groups.
Someone just
Crypto.
someone's Okay. Oh, there we go. So we can just go through. Yeah, let's just go through. I don't know the questions we didn't do, and we can like share this with if anyone's following online
Oh, okay.
in the future.
Yeah.
Maybe someone wants to take this course. All right. Let's see.
Can't say I really.
Okay. I have problems. I have solutions. I said 4. Okay. Oh, I should take pictures of my questions actually. Airdrop this to myself.
Yeah, I've been like writing stuff up
Ooh. Should we?
very nicely.
Do you want to telegram that to me?
I can.
Is this for exercise set 4?
Yeah, no, not exercise,
wow.
but earlier ones.
Oh, no, we can post it.
I can put them on. Yeah, I'll put it on GitHub or something, and then like.
Oh, we should do that. Yeah. All right, we'll airdrop this.
Finally, once it is still fun.
Yeah, I know. Okay. So, let's see. So, we went through some of these problems already.
Yeah.
So exercise, so 28. I think we said, yeah, it was just like examples of keywords, was just specific things, specific professions, like specific legal contracts or something. Yeah, like for a specific operation or something. Yeah. Okay. Exercise 29.
When you record, you end up recording the screen.
I'm recording the screen and pressing record. Should I block this? No,
It doesn't. But I feel like the screen.
yeah, it's on the screen. A little bit less. So exercise set 29. Exercise 29. Oh, we did this already. So we proved that this second term has to be positive. So we know that this is bounded at most bi of omega star. We know that this is at most bi of omega star because this is maximized basically. Yeah. I just wrote it formally here. Okay, that was not bad. Let's see. Okay. So 30. Okay, so actually I looked into 30 and they said it does specify that I think you can only get value from at most one good. So it says like someone's valuation for an arbitrary set S of goods is defined as the maximum valuation of all the goods that they like get basically. So it means if you get awarded like 5 goods, you only get value from the one good that gives you the most valuation. So it's basically saying every person just gets one thing. Because you wouldn't give someone something to someone that doesn't give them any value.
Right, I did.
But I found a paper where he talks about this, and he says this is like analogous to a maximum weight bipartite matching problem. Like if you have a graph, you have like, items on one side and bidders on one side, and you're just trying to find a matching 1-to-1 so that you maximize the weights of those edges basically.
Okay, so this basically ends up being like just auction every single good to the highest bid.
Not exactly.
Okay.
if you think about like, let's say your bid for good number one is like 100. Your valuation is 100 and mine is like 99 or something. And then for good two, your valuation is like 1,000 and mine is 1.
Oh,
If you already got the first good,
right. Oh, okay.
we actually want you to
think
have the second
about
good. So you actually have to like, run through all the possibilities. Well, you can use like linear programming or something to make it to do a polynomial time.
Okay, so probably like reduce it to bipartite.
Yeah, basically. I'm not super familiar with bipartite matching. I think it's like,
I kind of forgot what it was.
yeah, you basically like find subsets of matching, you find the optimal in those subsets, and then like if you combine all those subsets of like together, then you get the full set of like the best matching.
Sure. I forgot how
Honestly, is linear programming the same thing as dynamic programming? I don't think I ever did this. Okay. Oh man, this looks like a whole nother course.
bipartite matching.
Oh, it's you use a matrix, right?
Linear programming? Yeah, it's
I'm trying to like solve for a matrix. I don't really want to go into
I don't think we should go.
when it's possible.
I mean, I know where to find the answer.
Yeah. So for 31, with just bidders. Oh, okay, we did this one. It was basically with bidders 1 and 2. It's like any of them could get the good and they pay 1. Yeah. But if you add bidder 3 gets B, bidder 2 gets A, and then they both pay 0. So you lower the revenue by adding a new bidder. Does that ever happen in a Vickrey auction? No. You can only increase the payment, the revenue, the new bidder. So exercise 32. This was my example. So valuation of A for bidder 1 is 5. Valuation of bidder 2 of B is 5. Valuation of bidder 3 of getting A and B together is 11. So obviously the allocation rule is going to give it to bidder 3, right?
Okay.
But let's say bidder 1 and 2 lie, and they say they bid 8 instead each. They collude and they lie. If they bid 8, obviously they're going to win. So A will go to bidder 1 and B will go to bidder 2 and bidder 3 will get nothing. But they pay 8 minus 16 minus 11. Right? 8 is their bid, 16 is the total welfare, and 11 is the welfare if you remove any one of them, because then it'll just go to bidder 3. And So then they end up paying 3. So they get a positive utility, right, of 2. So in that case, they increase their utility. Their utility would have been 0 otherwise. They increase their utility with a false bid. Yeah. And this can't happen. And then they say, can this ever happen in a Vickrey auction? No. Yeah. Because, if you submit a false bid, either you overpay or you underbid, and then you just miss out on something, or you don't change your utility at all. Okay. 33 was consider a combinatorial auction in which a bidder can submit multiple bids under different names. So I guess like collusion or civil attack. The allocation and payment of a bidder is the union and sum of their allocation and payments respectively. Okay. Show that the following is possible. A bidder in a combinatorial auction can earn higher utility from the BCG mechanism by submitting multiple bids. So I just did the same thing, basically. So I said, bidder 1's their value of A and B together is 10. Bidder 2's value of A and B is 11. But bidder 1 can just submit 2 false bids, right? B11 of A is 8, B12 of B is 8. And the same thing happens where they end up paying, right, 3 for each. So they'll end up paying 6. And then they will have a positive utility.
Right.
This can't happen in a free auction. Let's say resistance again. If you create a false bid.
Yeah, you won't.
You could just increase the amount you pay, I guess. That's better. I don't know if I did 34 right. I feel like 34 was really simple. Did you look at 34?
I did. Let's see. I think the problem is I don't quite understand what's a fee symbols.
Oh, yeah. What was this last time? I can't remember. It's in the notes. I think it's just basically all options, no? It's just like while you can still
Feasible is
the remaining bidders can be repacked in the target range. It's basically the minimum amount of people so that like you can actually allocate all the bids. No? Right. The remaining bidders can be repacked in the target range. So it needs to free up a certain, I guess, certain number of people need to win, right? Be a certain number of women in the target range.
Oh, okay. So initially free up everything, and then try and add stuff and see if it's still pretty something.
Mm-hmm. People moving people until you can no longer free up enough spectrum. Yep. When people are bidding how much they need, how much money they need to be bought out. So obviously we get rid of the people who need the most money, and we just leave the people who are willing to be bought out for the cheapest price. Do a reverse auction.
Mm-hmm.
So I said to prove we're trying to prove that this allocation rule is monotone. So I said it's just like you can assume that it's not monotone. If it's not monotone, then if it's not monotone, then that means let's say there's a lower bid, there's a winning bid bi, and there's a lower bid b prime I that doesn't win. So meaning I could bid less and not win. I guess the definition of monotone is, I guess, reversed here.
Yeah.
Bidding less can only get you
More. Or more likelihood of getting bought out.
bidding less can't give you less.
Bidding
Bidding less can't make you not get bought out.
Yeah, I don't know how to phrase it because like
If you were getting bought out before, bidding less can't
Oh.
make it so you're not getting bought out.
yeah.
Bidding less can only increase your chance of getting bought out.
Yeah.
So I say if that's the case, that means there's a round where B prime of I makes the bidder get deleted, meaning the score was highest at one part in one round. But because the scoring is strictly is increasing in its bid, that means that the score of BI would have been even higher if BI is greater. And then that means that the bidder would not have won with BI either.
Yeah.
Which contradicts our assumption that the bidder won with a bid of BI.
Yeah. I don't know. This one is kind of.
So that's pretty trivial, right? Okay. Well, I guess that's exercise 8.
Yeah.
Exercise set 4, I mean. Exercise 7. Lecture 8. Yeah, I don't know. I guess that's it. Makes sense.
Bidding lower than cost.
Because your score will be lower for every round. Do you teach you? Cool. I guess that's it. Do we want to talk about the KF price auction? Or should we just leave that for...
I'm not sure what talk about it offline.
Yeah, okay.
I wasn't sure what the
group
following that was.
Okay. All right. Cool. Yeah.